To sketch the graph of this exponential function, we're going to start with our base function, our parent function, which is simply the base to the x. So here we have a base of 2, so 2 to the x is going to be the parent function that we are working off of. So I'm going to go ahead and graph that over, straight line. Graph that over here. This exponential function has a base of greater than 1, so this is an exponential growth function. So we know the y-intercept of it would be at 0, 1. And it's nice to use one other point to graph, and that's easy to plug 1 into this, and you get 2. And so the point 1, 2 is also a point on this graph. Okay, and then we just go ahead and sketch an exponential. And it doesn't have to be the perfect shape. We just need to know, we know that it's an exponential growth curve. So this is our 2 to the x, and I'm going to go ahead and actually make this a dashed curve because I'm going to be working off of this. All right, so there's our 2 to the x. Now I need to transform it into this function here. So there's some things going on here. First of all, I'm going to rewrite this here as 2 to the negative x plus 3, just because usually we're a little bit happier seeing that x kind of show up first. So there's 3 things happening here. Okay, we've got this plus 3, and we've got this negative, and we've got this plus 1. So those 3 different things are, those are 3 different transformations. We'll start with the plus 3, okay, because when you add or subtract a number from x, that is a horizontal translation, and that's usually the easiest thing to start off with when you are given the equation. So we have, and I'll go ahead and do it in red. We have 2 to the, and I'm just going to do x plus 3. Okay, that is a shift, a horizontal shift. The plus 3 means that we're going 3 units to the left. So this curve, I'm going to now move 3 units to the left. So those 2 points that I have are nice to track. So I'm going to take the 0, 1 and move that to the left. 1, 2, 3. And that point right there is where this ends up. Okay, same thing here, this point at 1, 2. If I move that 3 units to the left, that's going to be at negative 2, 2. Okay. And again, I'm going to go ahead and do this as a dashed curve. And that is the 2 to the x plus 3. The next thing we have is the negative in front of the x. So just taking this 2 to the x plus 3 and simply replacing x with a negative x. Okay. Replacing x with a negative x is a reflection in the y-axis. That's always kind of confusing because it's in front of the x, but it's a reflection in the y-axis. But an easy way to remember that is that if you are putting a negative in front of the x, then your x values are changing, not your y values. So when we take these points and we change the x values, we're going to be jumping across the y-axis. We take these same points that we have and reflect them across the y-axis. So that just means, of course, that we're going to flip the sign on each of our x values. So the negative 3, 1 becomes a positive 3, 1. And the negative 2, 2 becomes a positive 2, 2. And now we can see that actually the orientation of our graph has changed. Now finally, we have this plus 1 to deal with. And so we take the function that we have, and we add 1 to it. And if you take a function and you add 1, that's a vertical shift. And so we're going to go 1 unit, and the plus 1 means we're going to be going up. We're going to take our points, and we're going to move 1 unit up. So the point at 2, 2 goes to 2, 3. At 3, 1 goes to 3, 2. And we go ahead and shift our graph up 1. Now notice that the asymptote also shifts up. And so the asymptote which was at the x-axis is now up at y equals 1. So this green curve, that's our f of x.